Hello everyone, so welcome back to our last little video on related rates. So today what we're going to be working on is problems with right triangles. So these problems are generally going to deal with two things. One is SOHCAHTOA and the other is the Pythagorean theorem. And those are going to be kind of our two overarching things that we use as we solve problems that have right angles in them. Okay, but they're going to use the same strategies as yesterday, right? We're going to start with what is given. What are we trying to find? Take a time derivative and plug in. The math's just going to get a little gnarlier. Okay, so I have two big examples here I want to go through. So for the first example, let's say Mr. Gravel is standing on a point. So here's Mr. Gravel. I love Mr. Gravel. And he shoots his wife's cat out of a cannon. I'm going to try and draw this in a more school-appropriate way than I did last year. So here's the cannon. And the cat, gets shot out of a cannon in this direction due east. And it's going at 6 meters per second, and you are standing 6 meters socially distanced away from the point. So here's you, here's Big Dog Gravel, and the cat is over there. Okay, so at some instant, the cat is 12 meters away. At this time, what is the rate at which the distance between you and the cat is changing? So what I wanted to encourage you guys to do is to label this. So label your diagram. Like you guys are 5 meters north. You're not moving, Gravel's not moving. This is a constant. The cat's distance, let's call that x, right? Because that's changing. And when the cat is being shot out of the cannon at 6 meters per second, that x is increasing, right? It's getting further and further away. So dx dt is equal to 6. And at some instance, the cat is 12 meters away. At this time, what is the rate at which the distance between you and the cat is changing? So that distance between you and the cat, that distance, let's call that z. So this problem is telling me to find dz dt, the rate of change of that distance. Okay, so I need some kind of equation that relates the quantities I have. Well, I'm talking about sides of a right triangle because I have north and east and whatever. So I'm going to say that x squared plus 5, oh, that's a x squared plus 5 squared equals z squared. So this one is constant right here. Okay, so x squared plus 5 squared is z squared. So I'm going to now, I have my equation. So now I'll go ahead and I'll take a time derivative. So I'm going to take the derivative of both sides. Again, as always with respect to time. The derivative of x squared is 2x dx dt. Derivative of this constant is always 0. Derivative of z squared is 2z dz dt. Okay, now what do we know? Our goal is to find the dz dt. We know x, right? Because the x told us that cat is 12 meters away. That's x. That's saying 2 times 12. dx dt, that's the speed of the cat right there. That's 6. Equal, what is z though? I don't have a value for z. So the way I'm going to go ahead and find z is I'm going to need to go back to the original equation. When I need to find a variable, I'm always using an original equation, not a derivative. So when I go back to the original equation, I'm going back to this Pythagorean theorem. So I'm going to say, okay, when x is equal to 12, that's saying 12 squared plus 5 squared equals z squared. Now you can use the Pythagorean theorem. You can use like your special triangles or whatever. You know z is 13. Okay, great. So that's 13 right there times dz dt. So now let's just solve this problem. We can cancel the 2's out. So that's 72 equals 13 dz dt. So that's saying that my dz dt should be equal to 72 over 13. Let's think about a unit. Z is a distance, so that's in terms of meters here. T is a time, meters per second, so that should also be a meters per second. So that's how you solve the problem. When I had the missing piece of data I needed to use the original equation. But the key, I think, was setting up the Pythagorean theorem, labeling your variables. Always a good point to label. Even on the last picture, I labeled R, I labeled H. And that really kind of helped me set up the similar triangles in the last video. Okay, so that's this problem with Gravel and the cannon and his wife cat that he really hates. Let's go on to example 2. So this one, you're going to have to draw the picture yourself. There's some intersection in the desert. So two rows are intersecting in the desert. At some time t equals 2 hours, car Y is 8 miles north of the intersection. So I'm going to draw that out. That's car Y. Car X is 6 miles east of the intersection. Okay. Car X is driving towards the intersection at a rate of 10. Car Y is driving away from the intersection at a rate of 5. Okay. So, I mean, we can see it's a right triangle, so I'm just going to draw that out here. Let's call the distance z, let's call this x, let's call that y. It's a right triangle. Now let's see when car y is driving, car x is driving towards the intersection. So if car x is driving towards the intersection, hopefully you agree x is getting smaller. Right? If I'm going towards the intersection, this distance between x and the intersection is shrinking. So that's saying dx dt is actually -10 because that side length is getting shorter. Now, on the other side of things, y is getting bigger, right? If car y is getting further away, it's driving to the north, then that's telling us that dy dt is +5 because that y is increasing. So we want to think about, like, are these quantities getting further away are the quantities getting further or closer? And that'll tell you whether you're a positive or a negative there. Okay, now part A, find the distance between the two cars at time 2. Well, there's nothing talking about a rate, right? Well, this is just finding a distance between them. So in this case, our x is equal to, let's see. Oh, they told me car x is 6 miles east, car y is 8. So that's saying y is equal to 8 and x equals 6 at this point in time. Not constants, right? Those are changing. So when I want to find a, so I know x squared plus y squared equals z squared. So 6 squared plus 8 squared equals z squared. So you get z is plus or minus 10 with the square root. Obviously, we're not going to have a negative distance, so we're going to take the z equals 10. In terms of a units, that should be in terms of miles. Okay. Now, part B, find the rate at which the distance is changing. So now we have a rate. Now they're asking me to find the dz dt. All right, so again, I'm going to start with x squared plus y squared equals z squared. Now, when I need to find that dz dt, I need to go ahead and take a derivative. So that's saying 2x dx dt plus 2y dy dt equals 2z dz dt. Okay, now I'm going to divide a 2 off from everything. Cool. Okay, so when I plug in, and now I'm just doing plug-a-palooza, right? Like, I know y, I know x. At the same point in time, I can use a z. I know my dy dt and the dx dt, so I'll just plug all those in, right? So x was 6. So I'm going to have 6 times -10 plus y was 8, and dy dt is 5, equals, and the z was 10 times dz dt. So -60 plus 40, so I have -20 equals 10 dz dt. So -2 equals dz dt. Now, when we want to think about units, right, what are the units of z? Z is the distance in terms of miles, and this is the t is still in terms of what? I think it was hours? Yeah, they're miles per hour, right? We see that mph. So that's also in terms of miles per hour. Okay, so that's the distance between them there. Sorry, the -1y. All right, now let's get to part B, or part C of this problem. C, find the rate at which the area of the triangle is changing. Area, okay, so what they're doing is they're saying, what is the area of this triangle between x and y and z? Do we have a formula for area of a triangle? We do, right? So we know that the area of a triangle is equal to 1/2 times base times height. In this case, that's 1/2 times x times y. Okay, so let's roll with that. So that's the equation we're going to use. So I'm going to take the derivative of this, again, in terms of time. So I'm going to get dA dt equals 1/2. And then I got to use product rule, right? I have two variables multiplied together. I must use the product rule. So I'm going to say x times dy dt plus y times a dx dt. Okay, and now again, we have all these pieces of information. So it's a dA dt. The 1/2 stays in front. What is the x? Well, x is still 6. The dy dt is 5. The y is 8. And the dx dt is -10. We had to use product rule because x and y are both changing. Okay, so let's work this out. This is half of 30 minus 80. So I actually got a value of 1/2 times -50, so -25. Okay, so that tells you the rate at which the area of that red highlighted triangle up here is changing. Now we want to think about units. Area is two-dimensional, so that should be in terms of miles squared per hour. All right, so that's the process in part C. Let's look at D. This one's a little trickier. D asks us for the rate at which the angle at car X is changing. So we have some angle at there that I'm trying to find. the rate at which that's changing a d theta dt. Now, I can use any equation I want, right? I need an equation that relates that angle to the sides. So I need to use some trig function. But truthfully, I can use any trig or inverse trig equation you want. Now, if this were a situation, if this were a situation like the problem on the first problem up here, where we have like a constant, I would say, use an equation that deals with a 5, right? If your angle is here, you would make sure you use sine or tangent that had the 5, just because your derivative will be easier. But here we don't have that luxury. So because I have these like nice clean answers for x and y, I might use that. But I could really use any of them, right? So what I'm going to do is I'm going to start by saying sine of theta equals, okay, so that's opposite over hypotenuse. So opposite is y, hypotenuse is z. So I'm going to do y over z. I could have just as easily said the cosine of theta is x over z. I could have just as easily said the tangent of theta equals y over x. Like any of these would work. I just pick sine because it's the first one that comes to me usually, but you'll get the same answer no matter what. Okay, so now I'm going to take a derivative here. And again, I'm going to need the d by dt of everything. So let's think carefully about the left side. When you take the derivative of sine of theta, you still need to use the chain rule. It's cosine of theta times the derivative of theta, so times the d theta dt. When I take the derivative of the right side, I need to use the quotient rule. So it's a low d high minus high d low squared at bottom. Away we go. Okay, so that's how we're approaching this problem. Now, the right side, of course, is very easy. We can figure all these values out. So z was 10. dy dt was 5. The y was 8. The dz dt is what we found in part B. It's the same point in time. So that's -2. And at this time, of course, the z is still 10 squared. So I needed to use the chain rule to get the d theta dt. That's what I'm trying to find. But the question that you're probably wondering about is, how do we find the cosine of theta? How do I get cosine of theta? Now, the great news is thanks to the wonders of trigonometry, you don't even need theta. Right? You can find this without ever finding what theta actually is. Right? Because you can think, again, of SOHCAHTOA. Think about it as an adjacent over a hypotenuse. So at this point in time, we have this triangle when y is 8 and x is 6. So we have this triangle where we have a 6, 8, 10 triangle. So if this is my angle, at this point in time, the cosine of that angle, adjacent over hypotenuse, is 6/10. So that's what I'm going to use. I'm going to replace, now again, I don't know theta, but what I do know is I know cosine theta from the triangle. I know adjacent over hypotenuse is 6/10. So that's saying 6/10 times dHdt equals this fraction. So that's saying 3/5 times d theta dt equals, let's see, 50 plus 16, so that's 66/100. So that's saying that my d theta dt is equal to 66/100 multiplied by 5/3. That was 5/3. Okay, I can cancel this. 5 and 100 is like 1/20. 3 and 66 like 1/22. So it's like 22/20. I guess you could say 11/10 or whatever. And that would be, let's see, the units would be in terms of radians. And that would be radians per second. Sorry, per hour. It's radians per hour. Okay, so that's what's going on there. That's how you solve this problem. So that's the key idea, I think, is starting with the sine theta is y over z. Take the derivative of that. Use the quotient rule. Make sure you set up the chain rule carefully. And then just plug in all the values you know, right? Like we know already that y is 8. We know already dy dt is 5. And then we can kind of use all that to help us solve this. Okay, so that's how you deal with triangle problems. Thanks for watching. Let me know if you got more questions. I'll see you guys soon.